this is Captain Chaudhari in my series of videos on marine astronomical navigation. Today I am going to talk about a few interesting things about moon. But before that, let me define the solar day, sidereal day and a lunar day. Let's say here you have sun. Don't go by proportion. Just to illustrate the things, I have drawn the things in different proportion. Like we can see the pole of the earth, and there is a person standing here, right, vertically under the sun. That means the observer's meridian and the sun's meridian is same, right? And incidentally there is this moon also, right? We can say the moon, sun as well as a distant star are on observer's meridian, and the earth, as you know, spins anti-clockwise eastwards. The moon also revolves around the earth in anti-clockwise fashion. Now as the earth completes one spin or rotation in space, what will happen is the observer once again comes in this position, and the same distant star the observer will find in meridian. So we say that this is completion of one sidereal day. Sidereal day means spin of the earth by 360 degrees in space, right? And we may say that this meridian, as it appears in this diagram, is parallel to this meridian. So that is completion of a sidereal day. But this man who had the sun on his meridian feels that the rotation is not yet complete, because a sun is a very important heavenly body to decide our day-to-day activities, the domestic activities. He feels that the day is not complete, and he waits for 4 more minutes approximately, and the earth in that time would spin a little extra, and the sun will come on meridian. This is completion of a solar day. Solar day is about 24 hours, sidereal day is 23 hours, 56 minutes and 4.1 seconds. But now what happens is the moon, which was on meridian at the time when sun was on meridian and the star was on meridian, the moon has advanced ahead in its orbit. Now I will exaggerate the movement of moon. Don't go by the proportion. Just to explain this concept, I will draw the earth here, and this man, he does not find the moon on the meridian because moon has advanced in its orbit and moon has reached here. So by the time earth turns little extra, so that this man comes under the moon, would declare the completion of his lunar day. So on the average, lunar day is about 24 hours and 50 minutes, a little bit here and there, plus minus. Fluctuation is there. Lunar day is not of a fixed duration, but on the average, let's say it is 24 hours and 50 minutes. So that is sidereal day, solar day and the lunar day. Now we will talk about a few interesting things about the moon. And the first thing that I'm going to talk about is why we see the same side of the moon, why we cannot discover the other side of the moon, why whenever we see the picture of moon we see the similar features. The poets and the thinkers, those people who write about moon, they have said various things about the spots or the markings which we see on the moon. But let's discover why we see only the same side of the moon. To explain this concept, I asked my students to imagine that there is a boy with a balloon, and this big balloon has got one side as white and the other side as black. Now this boy is asked to revolve the balloon around him. He will never be able to see the other side of the balloon. Wherever the balloon goes, he will see only the white side. Wherever the balloon goes, he will only see the white side, right? He will not be able to see the opposite side. This is what happens in case of moon. If you closely observe, you will find that as the balloon completes a revolution around the buoy, the balloon has also completed a cycle of rotation. For example, if you start from here, the balloon is like this, then the balloon is like this, then the balloon is like this, and then the balloon is like this, and once again the balloon is like this, which means that in this cycle the balloon also has rotated once on its axis. So this is what happens to the moon. The rotational period is same as revolution period. That's why we are able to see the 50% of the moon or half of the moon or the same side of the moon from the earth. But there is a good news also. Actually, if you want to picture, at some time or the other we are able to see little extra in the longitude or little extra in the polar areas. This is called libration in longitude and libration in latitude respectively. Why this happens? Libration in longitude is attributed to elliptical orbit, and liberation in latitude is attributed to 6.7 degrees inclination of moon's rotational axis about normal to plane of ecliptic. So these are the two things, the reasons for liberation in latitude and liberation in longitude and liberation in latitude respectively. Now first let's talk about liberation in longitude. Suppose this is the earth here and this is the orbit of moon. At some time the moon is closest to the earth, like in case of earth and sun. The earth, when it was closest to the sun, we used to call it perihelion, closest to the sun. This position of the moon will be called perigee. That means closest to the earth, and this position of the moon is called apogee. That means moon furthest from the earth. Now when the moon is closest to the earth, the linear speed is fastest, or linear speed is more than the average speed, whereas the moon is furthest. When the moon is furthest, the linear speed of the moon is slower than the normal. Assuming that the rotational speed is constant. Rotational speed which moon has acquired is after billions of years of the action between the earth and the moon. The earth's gravitational pull is responsible for this, and now what we find is the rotational period of moon and revolution period of moon, they are same. So assuming that the rotational period of the moon is constant, but moon sometimes goes fast, sometimes goes slow in the orbit. So what happens is, because of this, there is sometimes the extra of the longitude on one side or extra of the longitude on the other side is visible from the earth, right? This is called liberation in longitude. Now other thing which I want to talk about is the liberation in latitude. If we look at the celestial sphere diagram, and let us say this is the equinoctial and this is the ecliptic. Actually the earth may be considered at the center of the celestial sphere, and equator might be considered as very small compared to the size of ecliptic. But in celestial sphere, in the concept of celestial sphere, we say everything can be projected on the celestial sphere. Distances are not important. So the equator appears such a big circle on the celestial sphere, right, as equinoctial, and this is the extension of Earth's orbit around the sun. It is called ecliptic. We know the angle is 23.5 degrees. So this angle is also 23.5 degrees. But moon's orbit, if we say that the moon's orbit is this way, actually moon's orbit is very close to the earth, but we are able to extend the moon's orbit also on the celestial sphere, and moon's orbit is found in the same celestial sphere as we find ecliptic. This is about 5.25 degrees. And when the moon is here, don't go by the proportion. Suppose we say the moon is over here. Moon's axis of rotation is not perpendicular to the orbit of Moon. It is inclined by about 1.5 degrees, right? So totally we get the advantage of 1.5 degrees plus 5.25, approximately 6.7 degrees of inclination. So what happens is, when we look at the Moon from the Earth, sometimes we see the Moon here, sometimes we see the Moon here. The idea is, sometimes we are able to see a little extra on the north pole of the Moon, sometimes we are able to peep a little extra over the south pole of the Moon. This is called libration in latitude. So libration in latitude is attributed to the inclination of the orbit of rotation of Moon this way, totally by about 6.7 degrees to the ecliptic, whereas liberation in longitude is attributed to the elliptical orbit, giving rise to perigee and apogee.